Hello everyone. In this video, I will show you how to evaluate the limit of f of x to the g of x when x is approaching a, and 4 steps when you have an indeterminate form 0 to the 0th power or 1 to the infinity. So the first step is to set y equals f to the g of x. Then you take the natural log of both sides, you get ln of y equals g of x ln of f of x. Then you evaluate the limit of ln of y by L'Hopital's rule if needed. So if this limit is equal to L, then the limit of y will be exponential of L. So let's look at this in the following example. We want to evaluate the limit when x goes to 0 from the right side of this function x1 over ln x. As you can see that this function is well defined when we are closer to 0 from the right side, and when x goes to 0 from the right side, you get a 0 to the 0th indeterminate form. So we can use the 4 steps. So we set y equals x1 over ln x. Then we take, so this function here, because we are on the right side of 0, this is always positive. So I can take the natural log to get 1 over ln x, and this is, since we are closer to 0 from the right side, ln x is different than 0, so this is equal to 1. So this function here is always closer, is equal to 1 when we are from closer to 0 from the right side. Now we take the limit, which will be exactly 1 when x approaches 0 from the right side. Then the limit of y will be the exponential of 1, and this is the end of example 1. Now example 2 is to evaluate the limit when x goes to infinity of 1 minus 3 over x to the power 2x. So as you can see, when x goes to infinity, this base here goes to 1 and the exponent is going to infinity. So you get 1 to the infinity indeterminate form. So we use the steps, set y equals 1 minus 3 over x to the power 2x. Then you hit both sides by natural log ln, you get 2x ln 1 minus 3 over x. So when x goes to infinity, so this function here goes to infinity, and this one will go to 0. So infinity times 0 is in the indeterminate form. So if you want to use L'Hopital's rule, you have to write this function as a fraction of two functions, like this. So you get 2 times ln 1 minus 3 over x over 1 over x. If you flip it, multiply by this function, you get back to your own function. So now when x goes to infinity, you see this function here on the top goes to 0, and this one goes to 0. So you get an indeterminate form, 0 over 0. So we can use L'Hopital's rule. So L'Hopital's rule, so this is the limit of this function over this one by L'Hopital will be the derivative of this function by using the chain rule. You get 2 1 over 1 minus 3 over x times 3 over x squared, and the derivative of 1 over x, you get minus 1 over x squared, and this simplifies to 6 over x squared minus 3 over 3x over minus 1 over x squared when x goes to infinity. And this also simplifies to the limit of minus 6x squared over x squared minus 3x. This is a rational function, so to calculate the limit at infinity, all you need to do is concentrate on the highest exponent, and the answer will be equal to minus 6. So now the limit of y will be just exponential minus 6, and this is the end of example 2. Thank you very much, folks.